Imagine being able to type just by thinking. No movement, no sound, just your thoughts. Well, this breakthrough gives a voice to those who have lost it. It also opens a door we may never be able to close. Here's how AI is decoding the human mind right now.
Let's get started with the details.
What if you could type just by thinking? It sounds like something straight out of science fiction, right? But believe it or not, it's happening right now. Today, we're going to decode the mind and explore exactly how artificial intelligence is learning to read our thoughts. Yeah, that's not a movie tagline. That's the reality of a technological revolution that's unfolding in labs as we speak. In this explainer, we are going to look at the Stanford breakthrough that made this all possible, the tech that literally listens to your brainwaves, and the huge, urgent question, what happens when our thoughts are no longer private? So let's get right into it. So, how can an AI actually read your mind? I mean, this isn't about some kind of psychic ability. It's pure science, and it's all about decoding the signals your brain creates for something you do all day, every day. Your own inner monologue.
Okay, this is where it gets absolutely incredible. Researchers at Stanford worked with participants who had severe paralysis, and they used a brain-computer interface to listen in on their neural activity. And they actually managed to interpret the brain signals from just the intention to speak. Think about that for a second. No movement, no sound, just the thought. This was the first time anyone had ever captured the signature of silent inner speech, a total breakthrough.
And the results? They're just staggering. The AI models they trained on these brain patterns hit a 74% accuracy rate in decoding imagined words. And we're not talking about just a few simple commands here. This was from a large vocabulary. This could literally open the door for fluid, natural communication for people who've lost the ability to speak.
So we know what they did, but how did they pull it off? The answer is in a piece of technology that creates a direct pathway from your brain straight to a computer.
The tech behind all of this is the brain-computer interface, or a BCI. Really, you can just think of it as a bridge. It listens to all that complex electrical chatter happening between your neurons, and then the AI acts as a translator, turning that chatter into commands a computer can understand, whether that's typing on a screen or moving a robotic arm.
Now, there are basically two ways to build this bridge. The invasive way involves surgery, placing tiny sensors right on the brain to get a super clear signal. But the real holy grail, the thing everyone's chasing, is the non-invasive path, using things like caps or scanners to read your brainwaves from the outside. It's way safer, obviously, but the big hurdle is trying to pick out the specific thought you're focusing on from all the other background noise in your brain.
And this is one of the most powerful non-invasive tools they have. It's an MEG scanner. And yeah, it looks like something from the future, but it's a real device that detects the super faint magnetic fields your brain creates when you think. This lets it capture thoughts with incredible speed. We're talking down to the millisecond, all without ever touching you.
So it really all boils down to this three-step process. First, the hardware, like that MEG scanner we just saw, records the raw signals from the brain. Second, an AI model sifts through all that incredibly complex data to find the specific patterns linked to a word or an idea. And finally, the AI translates that pattern into text. That's the magic trick right there. AI as the universal translator for the language of the brain.
And you should know, it's not just happening in university labs. Oh no, big tech is definitely in this race. This here is an experiment from Meta AI called Brain to QWERTY. They had volunteers type out sentences while recording their brain signals with non-invasive sensors. The big question was, could an AI learn to predict the sentences they were typing just by looking at their brainwaves?
And the results? Well, they show you exactly why researchers are so obsessed with this MEG technology. Using standard EEG signals, the AI made a mistake on about 67% of the characters. But with the more sensitive MEG scanner, that error rate was cut in half, all the way down to 32%. That is a massive leap forward, and it brings non-invasive tech much, much closer to the accuracy you get with surgical implants. This kind of progress has ignited a global race. I mean, we're talking about a field that is moving at an unbelievable speed, with major players from academia and the tech industry all jumping in.
The scale of this race is just immense. You've got top universities pooling their deep neuroscience expertise with the massive computing power of tech giants like Meta and Google.
And you've got these global competitions, like the PNPL Challenge, that are basically trying to crowdsource innovation from the entire machine learning community. Everyone is pushing to crack the code of the human brain.
This quote really says it all. You might remember, ImageNet was a dataset in competition that kicked off the whole revolution in computer vision AI. The goal here is to do the exact same thing for brain decoding. They want to create a huge, high-quality dataset of brain activity that sparks a similar explosion of innovation and breakthroughs.
So far, this all sounds like a miracle, right? A technology that can restore communication, maybe even unlock the secrets of consciousness itself. But every revolutionary technology has a shadow, and when it comes to decoding the mind, that shadow is very, very dark.
And this is the question that changes everything. As long as this is a tool for medicine, for research, the benefits seem pretty clear. But what happens when it becomes more powerful, more accessible? The potential for misuse becomes terrifyingly real. And look, these are not some far-off sci-fi scenarios. AI ethicists are sounding the alarm right now. So-called anonymized brain data could be traced right back to you. An AI could infer your political beliefs or even a medical condition without you ever saying a word. But the biggest danger is something researchers are calling consent collapse, where the whole idea of you agreeing to how your brain data gets used just becomes meaningless.
Let me break down what consent collapse actually means. Imagine a developer takes a dataset from a hospital, which is governed by really strict medical privacy rules. Then they combine it with a research dataset that's governed by a university ethics board. And then they stitch that together with data from some consumer meditation headband, which is only governed by a flimsy terms of service agreement nobody reads. You end up with one model trained on data with completely different levels of consent.
This brings us to the most critical question of all. We are really standing at a crossroads. The rules we write, or more importantly, the ones we fail to write, right now will determine the future of mental privacy for generations to come.
Just pause and really think about that for a second. Your thoughts have always been the one place where you are truly free, right? The final sanctuary of privacy. What happens when that sanctuary gets breached? When your internal monologue can be recorded, stored, and analyzed by an algorithm, does the very concept of a private self even exist anymore? Here's the bottom line. The technology is moving at rocket speed, while the law and the ethics are, well, they're still walking. And that massive gap between them, that's where the danger lies. This isn't a conversation for the future. It's an urgent debate we need to have right now. To stay informed on this and other breakthroughs that are shaping our world, make sure you subscribe.